Hi and welcome. I'm trying to learn particle physics. Today, matter, antimatter, imbalance, and after we've done it, we're going to do standing yoga. And if you participate in the standing yoga, then it's really obvious. A predecessor, which is part 6 of matter, antimatter, imbalance. A predecessor to the anti-proton decelerator at CERN, known as LEA, first manufactured anti-hydrogen atoms in 1995, but only in small quantities for very short times, and we jiggled about too much to do precise measurements on them. Now, already had in the previous class, there's antimatter and there's more matter than antimatter. And they could explain some of it through some counts, or whatever, but now the idea is they're creating, now there are always matter and antimatter. There's the proton and then the antiproton. And it has the opposite charge always. The proton has plus, and now the antiproton has a minus proton. The idea is now to create a neutral antiproton. I don't remember wherefore, but to do that. And that is done by slowing them down. So instead of using the Large Hadron Collider to make them faster, we're trying to make them slower, these hydrogen things. Slowing particles down. A dedicated machine, the antiproton decelerator, is fed antiprotons and calms them so they can begin to create stable unions with positrons and so form stable anti-hydrogen atoms. So we're giving anti-hydrogen in and positrons, the opposite of the electrons. So there are positive electrons with positrons and negative protons with antiprotons. And we have no idea that if they slow them down, these neutral antiprotons, that they exist for a long time enough to bind together with the positrons, the positive electrons, creating a new element, not hydrogen as a proton and an electron would do, but anti-hydrogen, but it would be neutral. It would be, no, I don't know what it would be. It would be an anti-hydrogen atom, whatever. They tried to do that basically. And in 1995 they made some anti-hydrogen already in small quantities. Marlborough's experiment, Asakusa, has been trying to solve these problems by making a de-excited anti-hydrogen beam that can be investigated by tickling it gently in flight with laser light. Okay, we were jiggling too much in 1995. I think that means that we're going from the third light. And now they're trying to make a laser out of this anti-hydrogen so that they're staying in one place. The collaboration reported the first tentative signs of success in 2014 and just recently more certain signs. Right now we are about to show we have succeeded in forming anti-hydrogen in this new way, says Marlborough. Okay, we were somewhere able to make anti-hydrogen in the laser beam so we can study it and have it in a fixed place. Meanwhile, Hengst's alpha experiment has stolen a march. Its approach is to cool anti-hydrogen atoms to within a whisker of absolute zero and hold them in suspended animation. So we want to cool them down to minus 270 degrees around, so that at that place the atoms start to move very slowly and keep them there. Its best effort is trapping more than 1,000 of them at once. At every step of this, people said that this would never work, said Hengst. You would never make anti-hydrogen. If you made it, you would never trap it. If you trapped it, you would never have enough. And now we have all those things, but all that has taken about 30 years. And it's only really worked in the last 3. Okay, he's saying the last 30 years we worked on creating anti-hydrogen by slowing negative protons and positive electrons down so that they exist for long enough time because they were slowed down to create a new element which is not hydrogen but anti-hydrogen. And now after we've created this anti-hydrogen, we are able to trap it with a laser beam and also to trap 1,000 of them at a time with a laser beam or cool down, whatever it is now. And that is what we did the last 30 years. And in the last 3 years we got pretty successful at it. In 2018, The Alpha collaboration published its first comparative measurement of the frequency of a hyperfine transition between two positron states in antihydrogen, showing agreement with a hydrogen value to a couple of parts in a trillion. I don't know what we're talking about. Okay, whatever. That might sound like conclusive evidence of nothing doing, but the hydrogen transition has been measured to 1000 times better precision, meaning there is still plenty of room for discrepancy. The hydrogen value. I think they're saying now they measured not how much antihydrogen there and hydrogen onto a few trillion parts exactly to find this matter-antimatter imbalance. Matter is normal hydrogen, antimatter is antihydrogen. But they're saying we are only able to measure it of a few thousand things precisely, and there's still room that there is an imbalance between matter and antimatter. And that would be important. I don't really get it, but that would be important, matter-antimatter imbalance. Because it means that the standard model is explaining this CP violation of this matter to antimatter in the same amount, and it would mean if there is this imbalance, then the standard model does not explain it. I think that is, and the standard model should explain everything. In the standard model, there are 17 particles in it, and they should explain every type of particle in the universe. But the standard model does not explain, as far as I have understood it, why is there more matter than antimatter. And the idea is now we're creating antimatter to look why is there the difference, but we could not find the difference. But it's not precise enough on a few thousands to know it. I don't know exactly what we're doing actually. Maybe I mixed two, three things up, but something like that. From the system, from the idea, things like this. How are we doing? In 2020, the team published a measurement of the even tinier Lamb shift in antihydrogen. This effect is caused by energy fluctuations in the quantum vacuum and should be very sensitive to any signs of unknown physics. I don't remember what Lamb shift was. I did it once in a video about that, I don't know what it was. And with that, we want to find out if there is a shift in energy between them. Again, there was no measurable difference compared with hydrogen. But any definite statement would require much more sensitive measurements. Okay, we're trying to find out if there is a matter-antimatter imbalance. Or is it that we know there is one, but we can't recreate it? I don't really know what we're talking about. Because we're putting a lot of effort into finding out if there is a difference and to measure it and how it is. Have we even proven that it exists? In late 2018, the anti-proton decelerator was switched off to be hooked up to a new machine. The extra low energy anti-proton ring, or ELENA, long-term ELENA. And so it's a new thing. They had the CERN thing, the CERN thing is the whole thing. They had the LHCb, the Large Hadron Collider Beauty Parade, and they had the LIR, I don't know if I said somewhere. So some other thing, and now we're having a new thing, ELENA, and that is the thing which makes the extra low energy antiproton, and ELENA makes it even slower. How these atoms are done. Long term, ELENA will enable antiprotons to be slowed even more, increasing by between 10 and 100 times the number that experiments can play with, and further increasing the accuracy which these measurements can be made. Okay, they're saying they built a new ring to drive their atoms in it, and that thing is able to make the atoms onto a tenth or hundredth of the speed as it was already in the LEARN thing, which was already slow in the LHCb. And now we're having a pretty slow thing where we have them running around, and we have no more time to measure what's going on with it. That was the particle physics part. If you're here for particle physics, you can go directly to the next part of particle physics. If you stay here and participate in the same yoga, it's better to honest. We have the feet standing together and breathe in and lift the arms down. And breathe out the arms down. In and up. Out and down. In and up. and open to the side. In and up, and open to the other side. In and up. Make an inch of space between the feet and open to the side. In and up. And sink down. In and up. And open to the other side. In and up. And out and down. In and up. And out and lean with the hands onto the knees. Standing cat and cow. Breathe in. And out, make a hill with the back. In again. Out the belly with the back. In into the middle. And out the head. In into the middle. And out the belly. In into the middle. And out, come with the round back up and make it the top of the good shoulder. Now breathe in and lift the arms up. And breathe out and open again to the side. In and up. Out the arms over the sides down. Breathe in, come halfway up. Come higher up. Now come up. Breathe in, reach high. And out, open to the side. And up. Out the arms over the sides down. In halfway up. High up and out and come up. Breathe in, come up onto tiptoes. And breathe out and sink down. This can go underneath. In and up again. Out and down. In and up. And out the arms over the sides down. The down like dolphin. Feet together and we're down. Breathe in, bend the right leg, the mountain. And breathe out and stretch the left leg. In and change. Out, stretch the right leg. In and change. Out the left leg. In and change. Out the right leg. In into the middle. Out and down. The penguin. Breathe in, lift the right hand to the sky. Breathe out, bend the left knee, look over the right shoulder to the right hand. In and down. Out and down. Breathe in, lift the left hand up. Breathe out, bend the right knee, look over the left hand, shoulder to the left hand. In and down. Out and down. Make a hand left space between the feet. Shift the weight to the heels. Breathe in and go down. Let it go. In and up. And out and down. In and up. And out the ambitious pelican, hands high as possible and with the toes up off the ground. In and up again. And now the chamber stays counterweight. Take hold on the elbows and gently rock from side to side. Hands come down, feet together, and breathe in, come halfway up with a straight back into monkey half. Out and down. In halfway up. Out down. Now breathe in, come up again with the arms, the updiving swan, hands together. Now the hands together and the elbows together, breathe in and reach high. And out and down. In and reach high. Out and down. And now go back with the hands. And breathe out to reach your front. In and back. Out and front. In. And have the feet standing too. Shoulders wide apart, intertwine fingers behind the back, stretch of Venus, bring the hands over to one side, tall up, shoulders back, breathe in. And breathe out, head over to one side, and chin down onto the clavicle. Breathe out, put the arm on the shoulder. Breathe in, lift the gaze, turn the head over to the other side, hands over to the other side, tall up, shoulders back, breathe in. And out, chin down onto the clavicle, pull the arm on the shoulder. Breathe in, lift the gaze, turn it back into the middle. Have the feet seam together, breathe in, lift the arms up. And breathe out, lean back, draw the shoulder blades together for crab in the morning. In and up. Out and back. In and up. Over cross the arms, intertwine the fingers, reach high as screw. Breathe in. And breathe out, reach it, one hollow the back, breathe out. Long snake curl. In and up. Over across the upper body arm, breathe in, reach high. And out, reach and roll out the back. In and up. And out, lean with long arms back, the sky up. In, up. And out and back. In and up. Out the arms down over the sides. And we're doing the eagle swings. Lift the arms up. Breathe in. Out and down. And just rocking flow. The arms up a bit faster. Out and down. And the cactus collecting its stings in the evening. Breathe in with the arms up. Bring the palms of the hands together and lower the hands down to heart center. It was standing over. Thank you very much. Until next time.